Okay, we're going to do example 3 from the slideshow now. This question is asking us to go in reverse compared to what we did in example 2. So we're starting with the pH, and we're being asked to figure out, okay, what mass, of hydrogen iodide gas would we need to dissolve in this volume of solvent to make a solution that has a pH of 4.22. So once again, hydrogen iodide, I should say hydroiodic acid, is another strong acid. So the only reason you can do these problems is because these are strong acids. If these are weak acids, then we cannot apply the the logic that I'm about to show you. That requires some extra thinking. Not to mention it doesn't work. It doesn't give you the right answer. So, but this though we can use because hydrogen iodide is a strong acid. The same logic applies to strong bases. These questions are only doable in grade 11 or Chem 20 because they're strong acids and we assume they go to completion. So let's figure this out. We got to figure out how much did I need of hydrogen iodide to bring about this solution. Well, I know that to get a pH of 4.22, my hydronium concentration has to be equal to 10 to the minus pH. So if I take my pH of 4.22 and I do 10 to the negative 4.22, this gives me a hydronium concentration of some number, but for my calculation I might keep it as 10 to the minus 4.22 till I get to the end, but as you can see it's a pretty small number. It's like 6.03 times 10 to the negative 5, right? I didn't even really conserve sig digs there, but I'm not going to worry about sig digs until I get to my final answer, but just for the record, this is what that number is. I'm going to keep working with 10 to the negative 4.22. There's nothing wrong with doing that. In fact, it's maybe a little bit more convenient. So that's my hydronium concentration. And I know that that concentration came about from a 175 milliliter solution. So now I need to figure out how many moles of hydrogen iodide were inside that volume of solution to give me this many moles of hydronium ions. And remember, the assumption I'm making here is that it's 100%, so however many hydronium ions, however many moles of hydronium I have, is equal to however many moles of hydrogen iodide I have. So the number of moles of hydrogen iodide is equal to the concentration of hydronium times the volume. So this equals 10 to the negative 4.22 moles per liter times the volume, which is 0.175 liters. So that tells me my number of moles of hydrogen iodide. Now, if I know how many moles of hydrogen iodide I have, I just need to figure out my mass of hydrogen iodide. And that's going to be however many moles I have of hydrogen iodide times its molar mass. And hydrogen iodide has a molar mass of, 126.90 plus 1.01. So 127.91. grams per mole. And then that'll give us the mass. Oh, what was I doing there? There we go. So I didn't fill in and substitute all the values along the way. I prefer to kind of just plot a little path of how I'm going to get to my final answer. So let's go ahead and figure that out. So we'll do this one, start with this one, 10 to the minus 4.22 times 0.175. There's my number of moles of hydrogen iodide. And now I have to multiply by the molar mass. Like that. Okay, and I get an answer of let's see, I should really only have 2 significant digits, so because of I only have 2 decimals, 2 digits to the right of the decimal up here, so 2 significant digits, I have 1, 2, 3, so that would be 1.3 times 10 to the negative 3 grams. And there you go. There's example 3. Kind of a trickier question, especially because we kind of start from the reverse, the last step in the previous example. Once again, we're going to find it helpful, at least I find it helpful, to plot out my calculation. This is going to be really true when we study stoichiometry. There's going to be lots of conversions back and forth, so I'd like to have this kind of nice visual reminder of where I'm starting and where I'm going. All right, so that's it for example 3. In the next video, I'll look at examples 4 and 5.